In the previous video, we looked at how we calculate the x and y coordinates of the end of a vector that starts at the origin, given a length for the vector and the angle that it makes with the x-axis. You might remember we used some trigonometry to calculate those x and y coordinates for the end of the vectors. In this video, we're going to look at how we can now plot these vectors so that they are what are called head to tail, so that we can graphically represent their addition. So let's start by looking at the first vector. So the coordinates, the x coordinates are given by the calculation, the length times the cosine of the radians of the angle that it makes with the x-axis. Now we're going to leave A at the origin, but I'm going to start the change here by using the first one, even though it's going to stay at the origin, and I'm going to add the x-coordinate of the beginning of the vector to the x-coordinate of the end of the vector. Now in the case of the A vector, that's not going to make any difference because both the x and y coordinates for the beginning of the vector are 0. But it's important that we do this so that we can change the origin of the vector to any point, and in doing that we won't change any of the calculations that we need to undertake. So it's quite easy to do. We just select our algorithm or our formula either within the cell or up here in the formula bar. We can either select the end or the beginning, and I'll select the beginning just to represent it in the order in which it is added. So we're going to add the x-coordinate of the beginning of the vector to the x-coordinate of the end of the vector to give us the final x-coordinate. So to simply do that, we make sure that our cursor is blinking within our formula, and you can see that I'm up here in the formula bar, and you can see this vertical line blinking. Wherever that vertical line blinking is, that's where our entry will be made. So if we select the cell that contains our x-coordinate, which is the cell R8C3, so the intersection of row 8 and column 3, we select that cell and then we enter a plus sign. That will now add the initial x-coordinate to the final x-coordinate, and we'll hit enter. And as you'll see, we didn't see any change in our final coordinate. So let's do the same for our y-coordinate. Select the formula, and I want it at the beginning, so I select just after the equal sign, then I select the initial y-coordinate and then the plus sign, and then enter. Now, as I said, that won't make any changes, but now we can actually fill that across. So let's Control C this and then select. So I'm highlighting these first two cells here, typing Control C and then Control V for the paste, to paste the second coordinate, the final coordinates for the second vector, and then Control V to paste for the final coordinates for the third vector. Now I also realized that in this case we haven't actually changed the starting coordinate for each of the vectors. So let's quickly do that. So this will be just a bit of revision. So if I select that cell, I can see that I'm in the same row, 2 columns back. I move my cursor over the blue outline until it changes into this little hand, and I fill that down. Now, because that's a relative reference, moving one row down, given by the numeral 1 in the square brackets after the R, and 2 columns to the left, given by the -2 in the square brackets after the C. Now, wherever I fill this across to, that will always refer back to those coordinates. Now you can see I have created that graph that includes the vectors and shows how they are representative in the graphical form. So for example, now I can change the coordinates for my x and y. So let's make it 1, 1. So now everything moves relative to that changing coordinates. And that's particularly because I've included this addition in the first cell. So you might have been inclined, we have 0, 0 for our initial coordinates, because our formula doesn't make any difference when we have 0, 0, you may have been inclined to start here at vector B. But if we had have done that, then we wouldn't have seen this relative change. So it's important to try and make your spreadsheets as dynamic as possible. So I'll talk a lot about dynamic spreadsheets in this course, so keep that in mind, that you're striving to make your spreadsheets as dynamic as possible. So for example, now I can change the length of any of these vectors and the angle, and my vectors will change based on that angle. So wherever I put this vector, things will change. So I'll make this one 4 and I'll make that one 40. And you can see that I changed. Now I do have a little bit of a problem with these labels not moving to be aligned with the vectors, but I can just simply drag and drop them so that they do align with the correct vector. Because I've color-coded them, that's quite easy to see. To undo what I've just done, so that it reflects my first entry, I can just use this drop-down function here, this back arrow, to undo all the entries I've just made, or Control Z, Shift Control Z or Control Z, pardon me, on the Mac, or sorry, Command Z on the Mac and Control Z on the Windows version of Excel.